Okay, these are some problems from section 4.5. We're going to be graphing the sine of x, and what they want you to do is graph the sine of x and then the function in each on the same coordinate axes. So the first one was y equals 4 sine of x. So what we'll do is we'll first of all label our coordinates here, our little graph here. And since I'm going to go up to 4, I'm going to make my scale like this. So this would be 2, and this would be 4, -2, and -4, because my amplitude there is -4. Actually comes down this line. Okay? And then I divided my graph over here into 4 equal parts, because I'm going to call this 2 pi, because we know the period of the sine of x is 2 pi. So if that's 2 pi, half of 2 pi is 1 pi. This is pi over 2. This is 3 pi over 2. And let's just graph the sine function first. So we'll just do that like this: y equals the sine of x. So you can compare it. And remember, this is 0, so the sine of 0 is 0. Sine of pi over 2 is 1. That would be right between the 1 and the 2. Back to 0, -1, and 2. So it's going to be a little bit flatter, just by the scale, mostly because my amplitude is 4 for my other graph, so I didn't want to run out of room. So there's the graph of y equals the sine of x. Now let's do 4 sine of x, and basically it's the same, except here at pi over 2 I've got 4, 0, -4, and 2 pi, just like we talked about in class. It's just 0, then 1, 0, -1, and 0, except we multiply those by 4. And that's what we've got. I'll kind of move the paper here so I can draw it. All right, so there's number 1, and you can see the sign. And it looks like that because of my scale, all right? And then number 3 was going to be, let's see, do this in a different color. Let's say 3 was going to be y equals 1/3 the sine of x. So I'm going to make this a little bit bigger so it's a little bit easier to see. So I'm going to take my scale up here. And you know you can do a lot with your scale, so let me make the scale 1 here. I'm sorry, I'll call this 1 and call this -1. And you could do that, it's pretty arbitrary, and this is y and this is x. Okay? And then we graph the sine, we'll graph that in pencil again. Y equals the sine of x. And again, I'll label these as be 2 pi, pi, pi over 2, and 3 pi over 2. Might have been better to do these all on the same scale, but we can do it like this if we want. And then here we're going to go 0, and this will be 1, 0, -1, and back to 0, like we talked about in class. It's just those 5 points are all you need. And this would be the sine of x here in pencil. And it's different, but it's basically my scale is different. So you have that way of drawing it. And sometimes your scale is going to depend on the graph you've got, and that works whenever we do sketching or graphing. You might change your scale to conform to the curve we've got so we can see it all, and we don't have to have a real big old giant curve. So that's the sine of x. And let me graph my function 1/3 of the sine of x. So instead of being 1, it's 1/3. This would be 1/3. And this would be -1/3. You can see the scale there. And then back to 0. And that's what we've got. So that's that curve, okay? So there's a couple. Okay, that's 4 sine and y equals sine of x. You can see, and then we drew it, the scale, we changed our scale, so instead of this being 4, I mean, 1 would be down here if we looked at the original scale, so I expanded the scale because I've got 1/3, I want to be able to kind of differentiate that, so I changed my scale. And remember, we always just go 0, 1, 0, -1, and 0. Now in this case it'd be times 4, and this is times 1/3. So 0, 1/3 times 1 is 1/3. 0, 1/3 times -1 is -1/3, and 0. So you can see that. So. And in each case, this is the sine of x. Ooh, better put the sine of x there. So this is the sine of x. And this one was y equals the sine of x. And this was y equals 4 sine of x. And this one was y equals 1/3 sine of x. Okay? Hope that makes sense. Hope that helps.